That's funny. You guys are funny. So now, what I want to do is I want to do these side by side. Why? Most confusions come when you see logarithmic differentiation versus a L'Hopital rule for exponential, with exponents, not exponential functions, with exponents. So L'Hopital rule with exponents, you need a logarithmic thing. In logarithmic differentiation, you need a logarithmic thing because the exponent is the problem. You want to get rid of it, so you use logarithm. So let's start with this. And people carry it over the same, that's okay. I do it this way, so I remember exactly what's going on. And I do the same way I do. So when I'm taking the derivative of this function, now, a is the limit. When I'm taking the limit of this function, and let's go to x to positive from the right side. That makes it a little bit neater. What am I ending up with is a realization that I can't do this and I have to do, let me write that limit down. Don't forget this limit. Then I write exponential and ln and cosine of x over 1 over x. Why? Because I want to bring that 1 over x down, but I can't just go about and bring exponents down, can I? So what I do is I put exponential ln because the two of them simplify each other. Why do I not have e to the power and I have exponential? So it won't be messy, that's all. I mean, literally, that's the only time. So it will not be messy. This is e. The only reason is if you go e to the power, it would be very awkward and ugly. And you mess it up. Trust me. Yeah, and so that's the story. Now that I put in that thing in, so I have to do exponential and ln. Now simplify this part. It would be 1 over x natural log of cosine of x. So far, everybody okay, right? Now, the next part is that exponential is a continuous function. I can bring the limit in. No, I didn't do it again. So exponential stays, limit goes in. Okay.
Power of limit as x goes to 0.
Yes, so it would be e to the power limit of natural log or whatever. Which natural log comes up, yes.
Can you write it as e to the power of it, or would you rather write it as exponential?
This is like a lot of experience. I just didn't bring my hair at home. It happened while instructing everybody to go into the power and go messy. No, I'm just kidding. It's just, it gets messy really quickly. Trust my experience. Just write down exponential and make parentheses. Instead of going to the power, it's really messy when things go around. Okay, so now, so I will have exponential. Now, this is nice. ln, I know ln, I don't have a whole lot to do when other stuff are next to it. So what I do is I put it in a form that L'Hopital accepts. The form that L'Hopital accepts is 0 over 0 or infinity over infinity. And that's what I do. And you're supposed to, at this point, for L'Hopital rule with exponents. At this point, you're supposed to end up with infinity over infinity or 0 over 0. So let me see. In here was one form, 1 to infinity, which was an indeterminate form. Here, right here is, no, right here is infinity times 0. Now I switched it to 0 over 0. So that's how it went. Forms are changing. And I think I didn't even say 1 to infinity, but the reason that I'm doing this is because it's indeterminate form, right? And so now, the next step is to use the L'Hopital rule, because I'm 0 over 0. And then here, L'Hopital rule, if the limit is not there, L'Hopital rule doesn't have any meaning. So these notations are very important. Natural log of cosine of x, derivative of that is 1 over cosine of x times derivative of inside, which is negative sine of x, divided by derivative of x, which is 1. And then, according to that, let's see, if I plug in, do I get something? I get limit, let me write it down clean. So if I plug in, I get 0 over 1. So it's all set. Now the limit is 0 because I plugged in. So it's exponential of 0, which is 1. So I did this one. You guys have to run? Okay, run. What I do is I get home and I do the rest of this. And hey, these guys, I think want you guys to see them.
I'm really focusing right now.
Just like trying to absorb as much as I can.
Very, very focused people. There you go. I'm glad you guys have your spirit for tomorrow. Keep your spirit. Let everybody know your time and their Zoom link. Are you feeling more comfortable? Do you know when to come to my Zoom meeting today? 5 o'clock. Okay. Do you want me to stop doing this? These people are enjoying themselves.
I saw that, Dean.
Okay. Jake, can you come forward and then I answer your question in case somebody should I stop the recording?
So this is actually a tech question. So I don't think I have gotten an email from you today specifically. So what should I do about that?
Oh, do you know your Zoom link? Do you know your Zoom link?
I know the Zoom links and I clicked the sign up. I just don't have the email specifically. In my
Oh, it's the email should say Matt125 and it should say, so it's from the Blackboard. I put every group and I emailed everybody separately. Yes. Sure. What's your name? Kate. Say Kate. And I know your name, but I can't remember it.
Because I don't usually, it's kind of a documentation I do in my head.
Yes, forms are not as, you can write one form down. So
Like
you
the
know
final,
that, you know
the
that,
first one and final.
yeah, but limits and stuff are important. That's something that you did tell us. When you're writing down the limits, then I know that you know
I got winner.
rising
I
state.
got winner.
Program without that limit in front of it does have, doesn't even make slight sense in mathematics. It makes an error basically. Okay, what's your
That's her.
Pierce?
Change it from approaching 0 just to approach
Dr.
0.
Nick Najad.
Okay, so here's the thing. If I don't know, it's just a little funky thing because there would be. I'm writing 1 to infinity, and if it pushes from left, it would be 1 to negative infinity, which is the same story.
Or it's like, so if I just did here and it's x goes to 0, would that be incorrect?
No, it's not incorrect. Both of them work the same, but the form, one is 1 to infinity, the other one is 1 to negative infinity. So, yeah. If I change this to negative, then it's 1 to negative infinity.
Or like, what happens if you just did x to 0 and you didn't approach it from the left to right?
It doesn't matter. It's all the same. The work is the same for both sides. Is this what I look like every time I talk to you guys? Is that what you're trying to do?
Wait, Professor, I have a question.
They're just making fun of me. Am I too close all the times?
Do any of y'all know when this review is? Or
Okay.
RIP. This is
I'm gonna troll you next time. Just watch.
stand on my head for 30 seconds. Not find out when this
Okay,
review.
Jake, what's the last question? Zoom people, do you have any questions?